Welcome to 7.3. Don't forget you have a quiz to do this week on a PDF and turn in. So that's 7.5. This, you're going to take the answers that you get from your on your own questions and submit them into the puzzle piece on Schoology, just like we did last quarter. So going back to what we did last quarter. Okay, so let's get into it. Last lesson, we talked about things happening in a row and how do you find the probability of things that happen one after the other. Last lesson, we only talked a very specific thing where it's the same thing happening every single time. So for example, we talked about how do you find the probability if you're getting the same prize 3 times in a row? Or what's the probability of you getting all 5 questions correct in a row? But now, what if we wanted to know the probability of something not the same thing, but different things happening in a row? So for example, what if you got the prize you wanted the first time, not the second time, but then again the third time? Or what if you got the first 4 questions wrong, but then you got the 5th question right? What's the probability of that happening? So that's where we're going to need some more organizational strategies, and we're going to use tree diagrams to do that. So let's talk about it. We're going to go back to that flip a coin example, and we're going to show you how to make a tree diagram for flipping a coin once to start off with. So what we're going to do is we're going to say each time I make a fork, it indicates one event. So when you flip a coin, you can either flip and get a heads or get a tails. Notice how I'm lazy, which is a good thing, and I'm going to just use H and T. So those are our 2 options. Then when we move forward to the second coin, well, first, let's talk about where do we put the probabilities. So when we're making a tree diagram, you want to put the probabilities on each one of the forks. So you have a 50% chance of each. So I could write it as 1/2, or I could write it as 0.5, or I could write it as 50%. For us, we're going to write it as a decimal. So we're going to say 0.5 here, and we're going to say 0.5 here. You could also write it on top of the line if you want. So you could write it as 0.5 here and then 0.5 here, just to indicate that the probability of going to the H is 50%, probability of going to the T is 50% as well. And I like to write 0.50 to remember that that's 50%. Now, the second flip of the coin, we are going to expand that. So notice how I'm kind of using the questions and keeping these in columns. So the second set of forks comes off of that. So this is what happens second. So we could say the first time we go to the H, then the second time we go to the H. That is one of the paths. And we know that the coin, these are independent scenarios, which means that the coin probability does not change. It's the exact same probability every time. And then the other thing that could happen is tails. So this pathway, this first pathway here, would be you get heads first and heads second. And in order to find the probability of that, which we found before, we would take the first probability and multiply it by the second probability. And we have done this before. And then we would multiply by 100, and we would get the probability of flipping a coin, heads first, heads second, and we would get 25% there. Again, sorry about my handwriting. I forgot my stylus at the school, so it's a little bit jacked today, and that's okay. All right, so now the second thing that could happen is that you could flip a coin and get heads first, and then flip it again and get tails second. And following the path, the first path says the probability is 50%, and then the second one says 50% also. And then we want to turn it into a probability, so we say multiply by 100, if I did that on my calculator, I would get 25%. And actually, this pattern continues because the only two things that could happen here and here are heads and tails, 0.5 and 0.5, 50, 0.50 or 0.5. So we could take a look here. This path, if we wanted to highlight it, that would be getting tails first and then heads second. And I hope that you can start to see, specifically with this situation, it's always going to be the same probability because it's 50-50. Not all of them are like that, however, so don't think that this happens every single time. It's just because it's 50-50 that we get the same percentage for all of the possible things that could happen. So what is the probability of both being heads? That's this path right here, this probability, so the answer is 25%. Okay, so hopefully that gives us a good idea of how a tree diagram works and what is going on. Let's go on and we're going to do one example here. And then you guys have 1, 2, 3 examples to do and some challenge problems. Those are optional. You don't need to do that. Okay, so let's read through the question. The question says, a certain student has a hard time waking up in the morning and often shows up late for school. From their attendance records, it is shown that the student is late, shows up on time 68% of the time. So I'm going to stop us right there. Notice how the tree diagram, it's already provided for you. It's always going to be provided for you for these questions, so no big deal. We just were given that it's 68% of the time you are on time. We want to put the percentage here, but I'm going to change that percentage. I could put 68 over 100, right? That's totally fine. But like we talked about last lesson, I like to change things into a decimal because then it's less typing. So I'm going to get my calculator out if you need to. Hopefully you're starting to see that there's a pattern when you turn something into a percent. It's the same number but as a decimal. So I'm going to rewrite this as 0.68, and that is the probability that they are on time. Now remember the complement rule. Now, either you're on time or you're late. There's no other options here. So, on time is 68. They both have to add up to 100. So, we're going to use the complement rule, and we're going to say, what is 100 minus 68? 32. So, we know that it's 32% or 0.32 there. Now, because these are independent problems, all of these problems, the probabilities never change, whether it is the first time or the second time, it's still going to be exactly the same probabilities. So feel free to copy and paste before you keep going. All right, so now we have our tree diagram all figured out here. Now what we're going to do is complete the tree diagram. So what does it mean to complete the tree diagram? It means to do all of this part, to get all the percentages written down. This part is really, really helpful. I don't have all the space in the world, so I'm going to try my best here. So we're on time and then on time. So the first probability that they would be on time on Monday and on Tuesday would be 0.68 times 0.68. Again, I forgot my stylus, so my handwriting is jacked also. Sorry, guys. Times 100. And then we can put that into our calculator and find our final answer here. So 0.68 times 0.68 times 100, 46.24. So we got 46.24%. Gonna make that so tiny. Want to make this fit right there. There we go. All right, so now the second thing that could happen is that, you know, this represents Monday and this represents Tuesday. So the first thing we found was that you know, on time, that's the probability she's on time both days. Now, it could be on time the first day and then late the second day. So how do we do that? We're going to do 0.68, that's the on time. Then we're going to multiply by the probability of late. Remember, that's the complement. Then we're going to multiply by 100. Notice I used dots instead of multiplication symbols this time. Means the same thing. All right, let's get that calculator split screened after that. So we got to change just the second number to 32, and we get 21.76. So it's 21.76%. All right, putting that there. There we go. Let's keep going. We got to do all of these. Now, as you do more and more of these, you'll start to see patterns and you won't have to do quite as many of these problems. Also, you get more and more efficient, so it'll get easier and easier. So now what could happen is she could be late on Monday and on time on Tuesday. So let's do that one. It would be the probability of late times the probability of on time times 100 to turn it into a percent. And maybe you guys are clever enough to realize that this is going to be the same as the last answer, because multiplication, it does not matter what order you do multiplication is. And the word for that is, it's called the commutative property. It means you can move it around and nothing changes. You don't need to know that. That's just a little extra bonus knowledge. You're welcome. All right, so 21.67 for that one. And then last but not least, we need to figure out what is the probability if you were late first and then late second also. So late on Monday and late on Tuesday. So the probability that you're late is 32 times 32 again times 100 to turn it into a percent. And I get 10.24 as my answer there. There are so many different things that you can do to save yourself time here. You don't have to write out everything. However, on a quiz or a test, I would definitely recommend that you write everything out, because otherwise I can't help you. If you get it wrong and I don't know how you got it wrong, I can't give you as much partial credit. So show as much work as possible. All right, so we completed the tree diagram. We have all the probabilities for everything that could possibly happen. And remember, this is different than the last lesson, because the last lesson we only talked about what would happen if she was on time, or late. Here, we could switch it up. We can say she was late one day and then on time the next day. So that's why tree diagrams are really helpful. All right, so let's now answer these questions. These should be pretty simple to answer. And I'm actually going to pause here and start another video in a little bit, because we just have a few seconds left on this one. So join me in the next video and we will go through and answer these next questions.